Hi guys, let's have a look at one of the questions that were in your exam, and that is question 8.2. Now, question 8.2 says, in the diagram, AD is a triangle with BC parallel to ED, and AE parallel to GF. It is also given that AB to BE is in the ratio of 1 to 3. AC is equal to 3 units, EF is 6 units, and FD is 3 units, and CG is equal to X units. So now they want you to calculate with reasons the length of CD. All right, so we have parallel lines, which we have learned in grade 12 that we can use the proportionality theorem, or the proportion theorem, which states that this side over this side is equal to this side over this side. The small part over everything is equal to the small part over everything. This part over everything is equal to this part over everything. Now we have to choose which one we want to use. But they give us that AB to BE is in the ratio of 1 to 3. So that's quite an indication to us. We want to calculate the length of CD. And this is given in the ratio of 1 to 3, meaning that we are going to use these loop T's here, meaning that AB over BE is equal to AC over CD. Now let's go write that down. So we can say AB over BE is equal to AC over CD. Now, I've taught you guys that this is the line parallel to one side of the triangle, but you can also actually just use the reason as proportion theorem and then state BC parallel to ED. You can also just give this as your reason. Okay, but let's continue. Now, AB in our diagram is 1. Over BE is 3, equal to AC, which is also given as 3 units, over CD, which is what you want to calculate. Now, obviously, when we do this, we can cross multiply. In other words, I have CD equals to 3 times 3, which is equal to 9 units. Okay, good. That was the first question. Calculate the length of CD, and we've done it. The next question asked to calculate the value of X. Now, you guys can see that X is the value of CG here. Okay, but in this part, we do not have the length of CG. We just calculated the length of CD. But I have no idea whatsoever what the value of GD is. I do not know. It's not given. I cannot calculate it yet. So what I can do is I can say, but DG over GA is equal to DF over FE. In other words, I am now working with these parallel lines here. So I can say that this over this is equal to this over this. Let's go write it down. So next I am going to say that DG, can you see that? Yes, over GA is equal to DF over FE. Once again, we have to state either proportion theorem or line parallel to one side of triangle or proportion theorem. We are now not using BC parallel to ED, but we are using GF parallel to AE. Okay, now if I go to my sketch, I can see that DG does not have a value. We must get a value there. So that's what we want to calculate. Over GA. Okay. Now GA here doesn't have a value, an exact value, but it does have an X and it has 3 here, meaning that GA is equal to X plus 3, equal to DF, which is equal to 3, over FE, which is equal to 6. Okay, but I want you guys to have a look at this little DG right here, because at the moment we have two variables, DG because we don't know what the value of DG is, and X. If I look at the line DG here, in the previous question we calculated the length of the entire CD. Now the entire CD here was 9 units. But does that not mean that DG is actually just 9 units minus X? So do you agree with me that we can actually then just substitute that into DG's place? So 9 minus X over X plus 3 is equal to, we can simplify that to 1 over 3, 1 over 2. If you would like to. Okay, so the next thing that we can do is we can cross multiply, and then we can say 2 times by 9 minus X is equal to X plus 3. If we want to simplify that, we can say 2 times 9 is 18 minus 2X is equal to X plus 3. Plus 3, take it over, 3x is equal to 18 minus 3 is equal to 15, divided by 3, x is equal to 5 units. And there you go. Now you have the value of x. And that was the whole question, 8.2.2. All right, now the next part of this question is to find the length of BC. Now BC is this side right here. Now let's see, BC is within the triangle ABC. Now remember, this is 1P to 3P. It's not an actual unit, it's just 1 to 3. So that's why we can say this is 1 to 3, meaning that these two aren't equal in length. Okay, so what we have to do now is we have to try and find something that correlates. Now, if I look at this small triangle here and the big triangle, these two sides are parallel, meaning that angle ABC right here will be equal to angle AED because they are corresponding. Angle ACB right here will be equal to angle ADE right there, because once again, parallel lines, they are corresponding. And angle A is equal to angle A because it is a common angle. So that is your whole proof. That's what you have to start with. So in triangle ABC and triangle AED, we can say firstly angle A is equal to angle A because it's common. Secondly, we can say that angle ABC is equal to angle A, corresponding angles, and BC is parallel to ED. And lastly, angle ACB is equal to angle D, once again corresponding, or you guys can use interior angles of a triangle. And then we can state, but triangle ABC is similar to triangle AED because of angle, angle, angle. Now from this, can you guys remember what we did in the first term? AB over AE is equal to BC over ED, which is equal to AC over AD. Can you guys remember that? So AB over AE is equal to BC over ED, which is equal to AC over AD. And that is because the triangles are similar. Okay, now let's see. We want side BC. So this definitely needs to be in our equation. So BC over ED needs to be there. So BC over ED needs to be there. We have an actual unit for AC. And we have an actual value because we calculated X, we calculated the side, we can calculate AD as 12 units, so we can say over AD. So AC over AD, meaning that we are going to work with this ratio right here. And then we can say, thus BC, which we want to calculate, over ED, that we have calculated as 9 units, is equal to AC, that is given as 3 units, over AD, which we have calculated as 12 units. Once again, if we cross multiply, we can get BC equals to 3 over 12 times by 9 is equal to 2 1/4 units. Okay, now the last question here asks you for the area, calculate the value of the area of triangle ABC over triangle GFD. So watch out which angle you are looking, triangles you're looking at. It's not this triangle over the big triangle. It's this small triangle over this small triangle. Now let's look for some similarities between these two triangles. Firstly, we said angle C is equal to angle D because they are proportionate. No? I'm sorry, corresponding. Next, look here. But AC and FD are equal. Now, they're asking for the area of these two triangles. All right, now the area of a triangle is half base times perpendicular height, not just any random height, perpendicular height. Now, I don't know about you guys, but I do not see any 90-degree angles to give me a perpendicular height within any of these two triangles, meaning I cannot use that formula. So I need to use my area rule. Now, if you guys cannot remember the area rule, the area of triangle ABC over the area of triangle GFD is equal to half side times by side times by sine C. This is the area rule, just quickly to recap for you guys. But within your exam, you can't use AB sine C. You need to state the actual sides. So remember, it's the one side and the other side, and the side that you didn't use, that angle. All right, now let's look here quickly. This is angle A, meaning that this is side A. This is angle B, meaning this is side B. This is angle C, meaning this is side C. So within triangle ABC, what do I have? I have BC and I have AC. So which angle do I need to use? Angle C right there. Okay, so we're not going to use this. We have to say this is equal to a half AC times BC. And yes, we are going to use angle sine C. All right, in the other triangle, we have the side opposite this angle, that's G. We have the side opposite that angle, that's F. We do not have this side, so this is going to be the sign that we are going to use, sine D. So this is, in other words, half of GD times by FD, and then we are going to use sine D. But hold on a moment. Sine C, sine D. Did we not say that angle C and angle D are equal because they are corresponding angles? So When we substitute now, we can actually substitute any one of these two into each other because it's the same angle. So AC is equal to 3, so it's a half times by 3, times by BC, which is 2 1/4. Let's do sine D, substitute C with D, divided by half of GD, which is 3 units. No, sorry, that's 4 units. Times by FD, which is 3 units, and this is also sine D. And what I see now is that sine D and sine D is the same thing. Half and a half will cancel. We can actually also say 3 and 3 cancels. So 2 1/4 divided by 4 is equal to 9/16 units squared because it is an area.